side, and we're gonna do some other stuff. You remember how to write this number 1 as a fraction? What goes on the bottom?
1.
1, yeah. And then you gotta make a common denominator here. The common denominator is x plus 2. You multiply the top and the bottom by x plus 2. This is -1 over x plus 2 plus x plus 2 over x plus 2. Now, since the bottoms are the same, that's key. Since they're the same, you can then combine the tops. So it's -1 plus x plus 2 over x plus 2.
Okay.
Are there
What
any
are we,
like terms? Sorry, question?
yeah, I'm just like, what are we trying to solve for here?
We're just rewriting it. It'll say something like rewrite as one fraction.
Okay.
And we do that to help with some of the things, not everything, but
Okay.
are there any like terms in the
Yeah.
numerator?
X and 2.
So actually it's just the -1 and the 2.
Okay. Not the
Does
X.
that the x is its own thing.
Okay.
So
Got
x
it.
plus
Um,
what is -1 plus 2?
1.
Okay. All right. So there's your reduced form.
Okay.
Any questions on that?
Uh, no, it's I get
All
a
right.
little.
So now we can go back to doing some things. We can find the x-intercept. The x-intercept is when the numerator is equal to 0. So you said x plus 1 equal to 0.
Okay.
So could you solve that for x?
Yeah. Uh, numerator would it just be -1?
Yes. So x equals -1. Um, that's the ordered pair -1 comma 0. So you go back to your graph and you plot that point. -1, 0 is about there. And then the next thing you find is what's called the y-intercept. That's when you set x equal to 0.
Mm,
So in both cases, we're using this. So it's 0 plus 1 over 0 plus 2. That's 1/2.
okay.
So there's that point. And then, without getting into y, we'll talk about, we'll just graph this here for the first one. Any questions on that?
No, I mean, I think the part that's confusing is just rewriting a little bit.
All right, well, let's do a couple of those problems because that is kind of a core thing here to be able to do. So let's look at a new example. Let's say it's 1 over x plus 3 minus 2. All
Okay.
right, and we're going to rewrite as one fraction. All right. So first thing is you got to be able to write that number 2 as a fraction. So it's really 2 over 1.
Okay.
And then you have to make a common denominator. What's the common denominator here?
Um, for both terms.
Yeah, like
Oh, well,
it's
last time we multiplied it by the first the first we did x plus 3 basically. We did the
yeah, you're gonna do the same thing here. You're gonna multiply by x
okay.
plus 3. So this becomes 1 over x plus 3 minus 2, x plus 3, x plus 3 like that.
Okay.
So this is where it's a little bit different. You you're gonna end up multiplying in by the 2. But really, I'm gonna rewrite that slightly. Really, it's 1 minus 2 times x plus 3 in the top.
Okay.
So you're really multiplying in by -2.
Hmm.
So what does
Uh,
that become when you multiply in by -2?
uh, 1 minus 2x minus 6.
Very good. And then are there any like terms in there?
Uh, would it be
On the
the
top.
1 and the -6?
Yep. So that becomes -2x minus 5 over x plus 3.
Okay.
All right, so let's do another one. Y equals 2 over x plus 1 minus 1. All right, so what is the fraction here?
It would be negative or -1 over 1.
And then what do you multiply the top and bottom by to make the
Uh,
common denominator?
x plus 1.
All right, so now it's 2 over x plus 1 minus x plus 1 over x plus 1. But it's really in parentheses, and you're really attributing this negative to both. So it looks like this. It's 2 minus parentheses x plus 1. You're distributing that negative to both.
Hmm, okay. Um, so can that like x plus 1 term, can that ever be simplified for, or,
You're going to distribute the negative into both. So what does that
uh,
become when you negate both of
uh,
them?
negative x minus 1.
Good. So that becomes minus x, and then what is 2 and the -1? What does that become?
uh 1, and yeah.
There you go.
Okay.
Okay. You ready to try one on your own here?
Yeah.
All right, so let's go. Let's say it's y equals 3 over x plus 2 plus 4.
Okay.
It's about as easy as I can make it without introducing any signs or anything weird.
All right. Let's see. 3 over x. Two. Okay, I think I got it.
Give me your final answer.
4x plus 5 over x plus 2.
Okay. I'm gonna just show some work here in case you want to look at it later. 3 over x plus 2 plus, this ends up being 4x plus 8 over x plus 2. So I got something different here. I got on the numerator, it looks like you just didn't distribute the 4 to both. It looks like you might have had just 4x plus 2.
Okay.
So it's not a choice. They both get it. Does that work?
Oh, yeah, I just subtracted 3 from 8 instead of adding it.
Okay.
Yeah, okay.
All right. All right, cool.
Okay. Um, okay. I got 3x minus 5 over x minus 1.
Sorry, one more time. 3x minus 5 over
X minus 1.
x minus 1. Okay. How confident are you in your answer?
I'm more confident in this one.
That's good. That's good here. So it ends up being minus 2 plus 3x minus 3. It is 3x minus 5 over x minus 1. Very good. Okay, so now I'm going to introduce the negative signs. Those are the more difficult ones here. Let's say it's y equals 2 over x plus 5 minus 1. Just keep it relatively simple there.
Okay. Okay. I got 1x plus 7 over x plus 5.
Okay, so there's a sign error for sure in your answer. When you there's a negative here. Do you remember the example we did that had a negative?
Kind of.
Okay, let's go back and look at it because I think you're going to see that, what are you supposed to do with this negative? Well, it goes to both. And my guess is you didn't distribute to both in yours.
Oh, okay. No, that is correct.
All right, so why don't you give that another try, please?
So it would be a negative x plus 5 on the bottom as well.
No, that doesn't change. Just the top. It only applies to the top. So you're distributing that negative into both. 2 minus x minus 5.
Yeah, I got that part right. I got that part right though.
Okay.
Um,
Well, but what is 2 minus 5?
okay, I was just for some reason I'm taking the negative from the 1x or from the negative 1x.
Well, 2
That,
is positive, 5 is negative. What's the
yeah.
what's the result? What does it
Neg
become on?
so it'll be negative 1x minus 3.
There you go. Okay, let's do one more.
Okay. I got this. I'm just messing up the signs.
And this is practice. So this is legitimate, like real practice for that's something you really will do. Okay, let's do this one here.
Okay. Grab my pencil. Pencil, just that. Hold on. Okay, I got it. Sorry.
What do you got for me?
Um, negative 2x plus 7 over x minus 2.
Yep. Let's take a look here. All right, so this time the top you're gonna take that -2 and multiply in to both terms. So it becomes, like you said, it becomes -2x plus 4. And you were correct. It's -2x plus 7 over x minus 2. Okay, any thoughts on that?
No, I think I get it.
Did a nice job. Did a really nice job on that. All right, so now let's look at some more problems here. Let's say that f of x is 3x minus 2 over x plus 1. Let's talk about the vertical asymptote on this problem. Way back in the beginning
Yeah.
of our lesson today, we did a problem where I said, do this to find the vertical asymptote.
Yeah.
Remember what I said or how to do it for this one?
Set bottom to 0.
Yep. All right, can you solve that for x, please?
X equals negative 1.
Yes. Now, how about the horizontal asymptotes? This is a little different. We didn't do one in this form, but the top and the bottom have the same degree.
Mm-hmm.
So do you remember how to do this? It's the ratio of, do you remember? It's
Whatever
the
the vertical shift is.
it's the well, it is when it's in this other form. Now it's the ratio of the leading coefficients. 3/1.
Okay.
And then the x-intercept, what do you set equal to 0 for the x-intercept?
The numerator.
So 3x minus 2 equal to 0. Can you solve that for x?
Yeah. Um, let's see. And 3x equals 2. 2/3. Is that correct?
And the y-intercept, it's a little bit different here. You have to put 0 in for x back into this one right here.
Okay. Mm.
What does that become?
-2/1.
What does that reduce to?
-2.
All right, very good. All right, so let me give you another problem here, and you're going to find basically these same four things. And we'll see if we need to increase the difficulty at all. But let's say f of x is 4x minus 7 over 3x minus 6. So I'm looking for the vertical asymptote, the horizontal asymptote, the x-intercept, and the y-intercept.
Okay. Um, so the vertical asymptote would be 4x minus 7 over 0.
Nope. The last problem here, we set the bottom equal to 0. I gotta do that again
Oh,
here.
sorry, I don't know why I did tried to do the whole thing. Um,
It's late, my fault for starting late, but it's
yeah, x equals 2, right?
x equals 2. Good.
And then horizontal is just 4 over 3, right?
It's an equation though. It's not just a number. What's the start of the equation?
Uh, I don't know. I just heard you say lead coefficient.
Let's go back and look. Did I just write two numbers here?
No.
It's y equals, and then you
Okay.
can put the numbers.
Okay.
The whole thing is needed. That's the whole point of this. All right.
Yeah.
X-intercept.
X-intercept is let's see. 7 7 over 4.
Okay, and what if I wanted that as an ordered pair?
It would be 7 over 4 comma 0.
Yes. All right, y-intercept.
You had said it's different uh x set x equal to 0.
Yep, 0 and for x.
Okay. Can you scroll up a little bit to the uh or is this our equation? Okay.
This is our problem, yeah.
um -7 over -6.
Okay, what does that simplify?
7/6.
Okay, and what about if we want it as an ordered pair?
0 comma 7/6.
All right, very good. All right, let's have you try another one here. You let me know when you sort of had enough here of this. Um, I'll make this one a little bit different.
Probably one more. I don't know.
Okay. So would like, again, the vertical asymptote, the horizontal asymptote, the x-intercept, and the y-intercept.
Okay. Um. Vertical is 3.
It is not 3. It's 3 is just a number. It's got to give me something more more than that.
Is it x equals 0
It's
or x
x
equals 3?
equals,
Sorry.
yes, yes, it's an equation.
Okay.
And I'm not being picky. It's just they will ding you for that. Like I know what you meant, but you have to give the whole thing.
Yeah. And then the horizontal asymptote, y equals 9/1.
So this is I made it was a little deceptive here. It's the coefficients in front of the x. Is 9 the coefficient in front of x?
Uh, oh no.
All right.
So
So what is the coefficient in front of x?
y equals -2/1.
There you go.
Okay. And then x-intercept. Uh, let's see. I gotta write this one down. This one's going.
You're setting the top equal to 0.
Yeah, yeah, I got that. But I just, uh, yeah, it'll be 9/2, comma 0.
For okay, I see. You give me that. That's good. Okay, how about the y-intercept now?
Um, let's see. Uh, um, uh, uh, is it just 0, comma 9/-3? So
Yeah,
0, comma -3.
good. Yeah, really good. Okay. What other questions do you have, or what were the gaps here?
I don't. I think I'm good if that's basically how you solve what I need to solve.
I mean, there's more, but this is kind of the 70, 80% of it. And there's other little nuanced things. Uh,
Okay.
all right. Would you like us to continue doing more examples? Totally up to you. I'm happy to keep going here.
I mean, if there's like one other part of it that I need to know.
I mean, the only
Uh,
thing I think could be unclear is that like we started out with a problem like this, and it transforms into the following, like this. And certain things like the vertical asymptote um, is the same. Like it's still x equals -1. The horizontal asymptote is y equals -3. But like you said, it's sometimes you can get it from this, or you can get it from the ratio of the leading coefficients.
okay.
And then the x-intercept you really can't get except from the one on the right, -3x -4.
Mhm.
And then the y-intercept you can get from either, but it's easier to put it in the one on the right. That's why the instructor has you change it to this, because really the x-intercept and the y-intercept are easier from this form on the right.
Okay.
So you have to be able to convert between them, which is what we did a bunch of. Um, did you guys talk at all about domain and range?
No, I don't think we've talked
Okay.
about
All
that.
right. And so the other thing with the graphing is you should really graph as you go. We started doing that in the first one.
Yeah.
Get the intercepts, or I'm sorry, the asymptotes down first, then you graph the intercepts, and you'll see, you know, how to connect it.
Okay.
Any other concerns you might have?
I think I'm good.
Okay. All right. What can we call it here?
Yeah, that sounds good. I'm tired, man.
All right. Thank
Hey,
you very much. Sorry for the late lesson. It's just bad right now. We'll get you on a better schedule next semester.
okay, cool. Thank you.